Hi guys, today's problem is Task E AtCoder Beginner Contest 258. Here is the settings. We have infinitely many potatoes in a row, and we know the weight of potatoes. Uh, it, it is denoted by W, and the arrayed potatoes are potatoes are periodically arrayed. So like this, if n is 5, double 0, double 1, double 2, double 3, double 4, and then again double 0, and so on. So we want to pack them in order until the total weight of a box is greater than x or equal to x. And if the box weight exceeds x, then we prepare a new empty box and try packing again. We have Q queries about K. Our task is to answer the number of potatoes in the case box for each K. So let's think about this problem with the example. First, we have W is the W is the weight of potatoes, 3, 1, 4, 5, and X is the weight of box, uh, X is 14. Then first we put potatoes in the first box here. We begin with 3 and then we end with 3 because uh, if we add this 3, the box weight exceed 14 for the first time. The next box is this. We begin with the 1 and it ends 1. And then the next is this. So first the first box has 5 potatoes. The second box has 5 potatoes, and the third box has 5 potatoes. Uh, in this case, we have the same value 5, but that's just by chance. It's no meaning. So let's check the constraints. N and Q, which is N is the number of the period of potatoes, and Q is the number of queries. It is 0 at most, about 10 to the 5th, and X is at most 10 to the 9th, W is at most 10 to the 9th, same, and K is at most 10 to the 12th. K is the index of the box, and this value K is too big. We have to pay attention about the number. So we can't count the number of potatoes one by one from the first because K is too big. That's a caution. So let's let's talk about the solution. The first idea is think about the period. So we know the W, which is the weight of potatoes, have period. So therefore, the way of packing has a period, also period. So let's take example again. X is 14 and the weight is arrayed here. So then you notice that uh, this packing and this packing is uh, essentially same, and this is same as here. That's because we have only four ways to start packing. If you pay attention to the first weight, first potato in the box, this is 1, this is 4, this is 5, this is 3, this is 1. So these numbers have only four ways, which is the number, which is a period of weights of potatoes. So the period of the packing is at most n. This is a very important idea. So let's number the number potatoes from 0 to n minus 1 according to corresponding to the index of wi. So for each I is between 0 and n minus 1, you can find the next position to start packing with. Uh, I explain it with the example again. The, the first box has these potatoes, and then the next box is here. The next box is start with this one. So, and the index is corresponding to 1. So, the position, the current position of the box is maps to 1. And then uh, if you start with this one, you may end with this one, and the next box start with this 4. So the 1 maps to 2 like this. So you get a map from the current position of the box to the next position of the box. We call it F. This makes the problem easier. So what we want is this diagram. So first we start with 0, and then we want to calculate the value f of x, and then we want to calculate the value f of x, f of 0, and repeat it again. we repeat it again k minus 1 times, and then the here this last value in the subsequential process, this is the start position to pack into the case box. So if you find out the value, this value, uh, you you can easily count the number of potatoes in the case box. So the last task we have to deal with is uh, the calculate the f of 0. This is k minus 1 times. We need efficient way of operating f many times because, so as I said, k is at most 10 to the 12th. So we can't do the process one by one. We can do that. So we need more efficient way. Then I introduce you a well-known algorithm for doing that, which is called doubling method. Doubling method, we want to know these functions. So in the doubling method, we calculate these functions in advance. F squared means the function conversion of the function f and f. And the f to the fourth is same, which means the function composition of the f 4 times, and so on. If you know all the value of these functions, you can calculate f of any numbers of x. Let's let's explain about it with this example. If you want to calculate the f to the f to the thousand of x, first we write thousand as binary. This, so thousand is 11111010000 in binary. So we can factorize f to the thousand as follows. So then we can calculate from the left. So we know the value of f to the 2 to the 3 of x, and then we know the f to the 2 to the 5th, and so on. So if you know all the values of these functions, you can calculate the f to the thousand of x only by 6 multiplications. So this is very amazing. So good method. So let's write the doubling algorithm in the Python. So first we have to calculate doubling function of I and x, which means f to the 2 to the i's of x in advance. I is here and x means the start position of the box here, of the box uh, now. And uh, calculating all the doubling function, uh, we can use induction or dp. Uh, dp is same as induction, but dp the name dp is famous among programmers. The method is as follows. We If you want to calculate the doubling function of I plus 1 and x, which means f to the 2 to the I plus 1s of x, then we can factorize this as follows, like this. So this can be written as like this in Python. So it's very easy to code it, code doubling method. And then we notice that 2 to the 40th is greater than 10 to the 12th, which is greater than k. So uh, it's it's good to think I at most 40. So the number of doubling function we have to think about is 40 times n. So remember that x is the start position of the box. So the the way has the position has n ways at most. So 40 times n. So this is enough small to deal with. So we've solved the task E. That's all about task E. So thank you for watching. My AC code is on the description.